In this video, we're going to look at how to perform some mathematical operations on complex numbers. Just to remind you, here's a definition. A complex number is a number that can be written in the form a plus bi. This is your standard form, where a and b are real numbers. And of course, I, which is equal to the square root of -1, that's what makes it imaginary, is called the imaginary unit. And by definition, I squared is equal to -1. The real number a is called the real part, and the real number b is called the imaginary part. That's because it multiplies the imaginary part. So I did a video, or some videos, on simplifying radical expressions. I also showed you how to simplify radical expressions using the TI-89. Well, a lot of the operations that you do with radical expressions is what you would do with complex numbers. Because if you look at this, I is equal to the square root. Okay, so that's a radical. Okay, so many of the operations are very similar. So let's look at the first few problems. Perform the following operations and simplify. Write your answer in standard form, a plus bi. Okay, now addition and subtraction of complex numbers is pretty straightforward. Just think of the I as a variable, like x, y. You combine like terms, right? 2x plus 3x, you can add them if you have the same variable. So just think of I as like an x. And here we have 5 minus 3i. That's one complex number. Subtract another complex number, 2 minus 7i. So in this case, we're going to have 5 minus 3i, and then we're subtracting here, so we just multiply through by a negative, so that'll give me the 2 becomes a minus 2, the minus 7i becomes a plus 7i, and now you just combine. Okay, we have 5, subtract the real numbers with the real numbers, so 5 minus 2, that's going to give us a 3. Okay, and then the imaginary parts, just add the coefficients, just like you would in a minus 3x and a plus 7x. Add the coefficient 7 and a minus 3 is a plus 4. Bring down the I, and there we have it, 3 plus 4i. In the standard form. Okay, now if this had come out to a 0 here, you would just write it as 0 plus 4i. Okay, because it wants the form a plus bi. Well, let's say the i's canceled out and it just came out to a 3. Then you just put 3 plus 0i just to get it in this particular form. Okay, if that's what the instructions call for. Now, if you use a calculator, say the TI-89, you could enter it just like this and hit enter, and the TI-89 will give you this answer right here. Okay, just like with the radical expressions. Okay, let's clear this and let's go to the next one. Okay, we have parentheses 9 minus 2i multiplied by 5i. So again, this is just regular operations with the same thing you would do with multiplying polynomials, or a polynomial by a monomial. You should just distribute it properly. 5i times the 9 would give us a 45. I, and then 5i minus 2i. Okay, so multiply the 5 with a minus 2 coefficients. So this would be minus 10i. And then I times I is I squared. But remember that I squared by definition is a -1. So -1 times a minus 10 makes it a plus 10. So let me put the 10 on front first here. And then I get a plus 45. I. So the answer is a 10 plus 45. I. Okay, clear this. Okay, here we have a division. We have 5 divided by I. Okay, so that looks pretty straightforward. It looks like it's already simplified. But remember, since you're considering the I just like a radical, so in general, we don't want to leave an answer with a radical in the denominator. So we have to eliminate this I from, just like if you had the square root of 2 down here. Okay, so one way we can do it is we can multiply the denominator by I. Okay, that's okay, as long as we multiply the numerator by the same thing. Because by doing this, all we're doing is multiplying by I over I, which is 1. 1 times any number doesn't change it. You get the same number. So what does this give us then? This gives us a 5I in the numerator. In the denominator, we get I times I. That's I squared. But remember, by definition, I squared is -1. So all you got here is 5I divided by -1 would give us a -5. I. Okay. Now, if you were to use the TI-89 and then write this down, 5 divided by I, the calculator would give you -5I, which is a correct answer. Wouldn't give it to you in the standard forms. Here they want the answer in standard form, so there's no A here, so that's 0. So I just put 0 plus, and then we have minus 5I. That's your solution. Let's clear this. Okay, so this one here we have 7 divided, or 7 over 3 plus 4I. So the only problem here is we have an I in the denominator. Okay, now this is a little bit different here, because what we want to do is we want to get an I squared, because we know that I squared is -1, and that eliminates the I. So to do that, in this case, we're going to multiply this by what is called the conjugate of that complex number. And the conjugate, all it is the same numbers. Yes, instead of a plus here, it's just the opposite. So this is a plus, we put a minus over here. This is a minus, we put a plus over here. We get this. Okay, now that's legal as long as we multiply the numerator by the same thing. So this will be 3 minus 4I. Okay, so what do we get here? So again, here just multiply through, just like you multiply a monomial times a polynomial. In this case, it's a binomial. So 7 times 3 gives us 21. And then 7 times a minus 4I, multiplying the 7 and the minus 4 gives us a minus 28. I. And then here, because we're multiplying the sum and the difference of the same two terms, okay, we know it's like a plus b times a minus b is a squared minus b squared. So in this case, this will just give us a 9. 3 times 3 is 9. And this will be minus here. And then 4I squared, so that'll be 16. I squared. Okay. But again, remember that I squared by definition is -1. So this becomes a plus 16. So in the bottom, then all we have is 9 plus 16, which is 25. And then on top, of course, we have 21 minus 28. I. And that is basically the answer, okay? Except that one's in the form a plus bi. So let's just say, okay, this will be 21 over 25. We can break it down that way. Minus 28i over 25. So I can write it this way to get it in that standard form. 21 over 25. And then I put a plus here just to get it in that form. And then the minus 28 over 25. And then I'll have the I. Okay, so this 21 over 25 plus negative 28 over 25 times I is the simplified form of this problem. Clear this. Okay, next one, we're multiplying. So again, follow the same rules, just like you were multiplying 3 minus x, 3 plus x, or 3 minus y times 3 plus y. Okay, treat the I just like a variable. And just remember that if you get an I squared, the I squared, you can replace it by negative 1. Okay, so here again, I have the difference in the sum of the same two numbers. 3 minus I, 3 plus I. So that would just be the difference of the squares. So it'll be 9 minus I squared. Okay, you can do it turn by turn. 3 times 3 is 9. 3 times I is 3i. Minus I times 3 is minus 3i. Minus I times minus I is minus I squared. And then simplify, you get the same thing here. And just remember that I squared is negative 1. So 9 minus a minus 1, okay, makes this a plus 1. So it'll be 9 and 1 is 10. And then, just to get it in the form, we can write this as 10. The coefficient of the I is 0, because there's no I appearing anymore. So we just write this as 10 plus 0 I. This is your answer, 10 plus 0 I. And let's cancel this. Go to the next one. 3 plus I times 5 minus I. Okay. Okay. Just basic multiplication of 2. Think of this as just you're multiplying 2 binomials. That's like a 3 plus x times 5 minus x. Okay. So we multiply the first terms, we get 15. Okay. Multiply the inner terms here, plus 5i. And the outer terms over here, minus 3i. And the last term's I minus I multiplied, and it gives me a minus I squared. So then we go ahead and combine this. So again, I squared is a negative 1. This is a negative 1. So minus a minus, negative 1, that's a plus 1. So that's at the real parts. 1 and 15 is 16. And then we're left with these two. Again, I just had to go combine the coefficients. In this case, 5 minus 3 is 2, so plus 2i. It's in the standard form here. That's your answer. Clear this. And then in the last one, we have 2 plus 3i quantity squared. So you can look at this as 2 plus 3i times 2 plus 3i, okay, 2 factors, Or you can just use the shortcut method. It says if you have a binomial squared, it's the square of the first term, which is 4 here. And then double the product of the two terms. So you double that, multiply these and double them. That's 2, that's times 3i is 6i, double it, that's 12i. And then square the second term, 3i squared is a plus then 9i squared. Okay, but I squared is -1, so this actually becomes then a -9. Okay, so then we just combine the real numbers with the real numbers, and the i's with the i's, okay? Adding the coefficients or subtracting. In this case, 4 minus 9 would give us a -5. And we're only left with 12i. That's in your standard form. And that's your simplified answer. Okay, that's it. That's it for this video. Thanks for watching. We'll see you next time.